Okay, welcome to this next video on some content from Chapter 1 for Chemistry 161. And we'll be looking at some examples for scientific notation, and Sig Figs. Okay, so to get going, let's start with this instruction. So we want to put these numbers into scientific notation. And list the number of Sig Figs. Okay, so we'll have the number here. We'll have the scientific notation here. And we'll put the number of Sig Figs here. Okay. So the first example might be the following. Let's work with 3576 milligrams. So take a moment at this point to pause the video and see if you can complete the other two entries for this first row in our table. When you're done, you may resume the video to check your work. Okay, so we might start with the last column of information, counting Sig Figs. So we can see here in this first example that all these digits are non-zero. And so we're following rule number 1 for counting Sig Figs. And so we know that there are 4 Sig Figs in this example. Our scientific notation better reflect 4 Sig Figs as well. So that's why we've done this last bit of information first to help us there. So we know in scientific notation, the times 10 to and the exponent don't count. So we can automatically do that without really needing to consult the number Sig Figs. It's the coefficient out front in the scientific notation that we have to be careful with. So if we're going to move the decimal point from where it is here, so notice now I've put that there. I need to move it 1, 2, 3 spots over. So that tells me that I'm going to put a 3 up here for my scientific notation. Okay, so I moved the decimal point to the left, so I'm going to put a positive 3 on that. And now I can use the resulting number as my coefficient. So 3.576 is my scientific notation. And I also want to respect the milligrams units that I was given, so we're going to put that value here, milligrams. Good. So our next example is this number, so 0.00362, and we'll work with meters this time. And so again, pause the video here to complete the next 2 entries in our table, and resume when you're ready to check your work. Good. So let's count Sig Figs. We have some leading zeros that are only there to position the decimal point where it needs to be. So these leading zeros, the first one, the second, the third, do not count in our Sig Fig count. And then we have 3, 6, and 2. So this is a 3 Sig Fig number, and we need to reflect that in our scientific notation. Again, we can put a times 10 to the, and we can even put the meters here at this point. None of that it needs to be adjusted given the number of Sig Figs at this point. We can now count the number of decimal points. So we need to move it to the right this time. 1, 2, 3 to position this correctly for scientific notation. Again, the coefficients we want to be between 1 and 10, and so that's why we're moving it between the 3 and the 6. And so I'm moving 3 to the right, so this is going to be a -3 result on my exponent for scientific notation, and the number out front in scientific notation better have 3 Sig Figs. Okay, so 3.62 is our result there. Okay, next example, we'll do one for temperature. Let's work with 75 degrees C. And again, pause the video when you're to complete your work, and then resume when you're ready to check that. Okay, rule number 1 for counting sig figs applies here again, 7 and 5, non-zero entries. So we got a 2 sig fig number here. We're going to reflect that in our coefficient of the scientific notation. So times 10 to the decimal point is not shown, but I'm going to put it here momentarily. So there it is. I need to move it one spot over to get a coefficient that is between 1 and 10, and I'm going to end up with 7.5. I went to the left, so I'm going to put a positive 1 for my exponent, and this, of course, was degrees C. Next example, let's work with 3, 6, 2, 3, 7. 7, 5, and let's work with miles this time. And again, count sig figs and complete your scientific notation, or resume the video when you're ready. Okay, going more quickly here, we have all non-zero entries, so this is a 6 sig fig number. Let's go ahead and get our scientific notation ready. We're dealing with miles, so I can even put my units there. Decimal point needs to move 1, 2, 3, 4, 5. So that's going to give me a positive 5, given that I moved it to the left. And now I need to make sure that my coefficient here has 6 sig figs, so I'm going to include all of those digits. 3.6, 2, 3, 7, 5. Good. All right, next number, 0.15 kilograms. And go ahead and pause the video and complete your next 2 entries. Resume when you're ready. Okay, so 0.15, we have a leading 0 ahead of the decimal point. We're not going to count that in sig figs. The other 2 are non-zero entries, so this is a 2 sig fig number times 10 to the, we have to move the decimal point 1 to the right, so that's going to give me a -1, and I'll use my lowercase k and grams for the kilogram, and now I have a 1.5 times 10 to the -1 kilograms there. Okay, moving on, 1632 seconds. Again, complete the next entries and resume the video when you're ready. Okay, 4 sig figs this time. We're going to work with seconds times 10 to the, and we need to figure out how many spots to move the decimal point. So 1, 2, 3 to the left. So that's going to give me a positive 3 up there on the exponent. And I want 4 sig figs in my coefficient, 1.632. Good. One more here. Let's do 3,000 and, no, sorry, let's do 30.03 minutes. And again, complete the next 2 entries and resume the video when you're ready. Okay, so this one might be a little more challenging for determining the number of sig figs. Clearly the 3 and the final 3 here are counting. So those 2 are giving us at least 2 sig figs so far. We have 0 in between some significant figures at this point. So we have 2 zeros in between 2 significant figures. And so these internal zeros are going to count. And so we have a 4 sig fig number here to work with. So times 10 to the, and we got minutes. And the coefficient out front in the scientific notation, it better have 4 sig figs to get this right. Okay, we need to move the decimal point 1 spot to the left to get a number that is between 1 and 10. And so here we're going to do times 10 to the positive 1, and we're going to end up with 3.003 as the number there. Good. So hopefully this refresher for scientific notation and our exercising of our Sig Fig rules was useful for you. Let's move on to some additional examples where we have to write the number of, adjust the numbers to the correct number of sig figs. So let's look at these examples here. The instruction will be, write these numbers with 3 Sig Figs. Okay, so our first one, again, we'll have our number here. And then we're going to put our adjusted number, respecting a 3 Sig Fig rule, over here. And our first one we'll work with is going to be 74.59 grams. And go ahead and pause the video and complete the entry in this row to the right, this time again reporting only to 3 Sig Figs. Good, so hopefully you can see here that we need to truncate or cut off this number and stop it at this point and only use 3 Sig Figs. So it's kind of like going backwards this time. Instead of just counting, we need to determine a new way of reporting this number to only show 3 Sig Figs. So clearly we need the 7, the 4, and the 5 to give us the 3 Sig Figs. We can't leave it there because that is a tenfold roughly number smaller than the previous one. So we definitely need a 0 or something to occupy that space. Now, of course, we've adjusted this number incorrectly by our rounding rules. So let's go and make a better adjustment there. And instead show that this number needs to be rounded up according to our rounding rules, and position a 0 there that doesn't count because it's trailing and there is no decimal point. So that 0 does not count, and the 7, the 4, and the 6 do count as significant. 1, 2, 3, and this would be the correct answer there. All right, the next one, let's do something similar here. So 3, 6, 5, 3, 2. Let's work with meters this time and adjust that down to 3 Sig Figs. Pause the video and resume when you're ready. Okay, so again, we want to be here. So we're not going to have this rounding issue this time because the numbers after that third Sig Fig are smaller than 5. So we're going to be able to just work with 3, 6, 5. Can't leave it there because that's 100-fold smaller than what we want. So we better work with a 0 and a 0 there and put a meters to make sure that the scale of this number is appropriate and close to the number that was reflecting too much precision. So the 36500 or 36,500 is reflecting a precision in line with 3 Sig Figs. Okay, next example, 0.03674. We'll work with grams this time. Go ahead and adjust this number to 3 Sig Figs and resume the video when you're ready. Okay. So we want to truncate the number somewhere around there. 0.00367 is going to work to show that that's the level of final precision in the numbers. So 367. While we had a 4 there, we've chosen not to show it, and we're not even going to put a 0 or anything there because a 0 after this digit would indicate precision and therefore significant value. So we're not going to put a 0, we're not going to put a 4, we're just going to leave the number there to give us the new number with 3 Sig Figs. Okay. Next example, 9.99 kilometers. Go ahead and tackle this one and resume the video when you're ready. Well, hopefully you see here we want 3 Sig Figs, and we're given a number with 3 Sig Figs to begin with, so there's not much work to do here. 9.99 kilometers is the result there. Not much adjustment needed. Okay, another example, 65.35 6, and let's work with, say, degree Fahrenheit and transform this to 3 sig figs. So in this case, you can see here we want to have only a value reflecting only to the first decimal point position, 65 point, and we're going to now have that new number. The 5, 6 over in the tenths and the hundredths position, in the hundredths and the thousandths position is going to tell us to round up. So we're going to go to a 4. That is going to give us the right number of sig figs, and we're not going to list any values after that 4, otherwise those would count. Okay, so there's our final number to 3 sig figs precision. We'll give the correct units there. Let's do 123.9 milligrams and get the answer on that one and resume the video when you're ready. Okay, so clearly we need to go adjust to the whole units there, so the in that position indicated by the arrow. And so the 9 is telling us to round up, so we better put this number as 124 to give a 3 sig fig answer there. And let's do one final one here, 9.999 kilometers. And work on this one and resume the video when you've got an answer to check your work. Okay, so kind of like the one we saw a few ago, we want to work over to here. This time we're giving an example where we need to do a little bit more work and we need to round up. So we're going to work with rounding up this time. So this number, the 9 tells us that this number needs to be increased, and that's going to need to be increased, as is this. So we're going to have to go to 10, and automatically with a 10 we've got, well, as listed, 1 sig fig. I put a decimal point. Now I'm counting that 0. That's 2 sig figs. And if I put a 0, this will also count. So this is a 10.00 kilometers. To be even less ambiguous, recall that we can use scientific notation to be very clear on sig figs. So this is one way to show it. Another way might be to say 1.00 times 10 to the 1 kilometers makes it very clear that we have 3 sig figs in this coefficient and 3 sig figs in our number. Okay, hopefully those examples helped you exercise some of your scientific notation rules and